Hi everyone, welcome back and welcome to Module 2. In this module we're going to be planning our deployment for our hybrid network. We're going to use this module to come up with the details we will need for the demo which we'll be creating in the next module. We're going to start with planning our Azure address space. This will cover some requirements which our addressing schema must meet and what the addressing will be for our demo. I've come up with a simple network design which we will be basing our demo upon. During this module, we'll be discussing the design and implementation of the Azure and on-premises parts of the demo. Finally, we're going to talk about Windows 2012 routing and remote access services and the requirements we need to meet in order to connect our Azure and on-premises environments together. So what do we mean when we talk about address space? Well, basically, it is the range of addresses that will or are being used in a network. There are three blocks of private addresses which are used. They are 10.0.0.0, 172.16.0.0, 192.168.0.0. We once referred to these networks as Class A, B, and C. Nowadays we use classless interdomain routing, otherwise known as CIDR, or CIDR. So we don't use classes to describe ranges anymore. To keep things simple, CIDR is a way of subnetting networks into smaller networks to save addresses. You can identify a CIDR notation by a slash and a number following the end of an address. This slash number translates into a subnet mask which you can use to subnet the network. We're not going to cover subnetting in this series, so if you're interested in finding more out, you'll need to do a search using a favorite search engine. The reason I am mentioning CIDR is because we'll be referring to it quite a lot when describing our networks, and I thought it would be a good time to describe what it was without going into detail. Now that we have an understanding of what an address space is, we can move on to planning our address space. The first requirement for addressing is that addresses need to be unique to each environment. This means that we cannot have the same addresses in our Azure and on-premises environments. It is highly likely that if you're watching this series, you already have addresses for your on-premises environment. We're only going to be interested in the networks which are going to be routed across the VPN. We can only use private address spaces for Azure VPNs, so we're going to need to work out what private addresses we are going to use in Azure. The address space you decide to use is up to you. Some people like to keep everything within the same network class. Yes, I know I said we don't refer to them as classes anymore, but it's easy to say. 172.16.1.0/24 is quite a mouthful, while others may prefer to put their remote networks into different class. Say Class C or 192.168.0.0/16, so when they see that network address they know that it's not part of their on-premises environment. My personal preference is to use the higher subnets of the Class B range for my on-premises environments and the lower subnets of the Class B range for my Azure networks. So to describe this better, my production network would be from 172.30.0.0 to the end of the Class B range, and my Azure networks would start at 172.16.0.0 and end where appropriate. For our demo environment, I'm going to use the entire Class B address space and then subnet that in Azure, so I don't have a massive network to work with. Now that we know what address ranges we're wanting to use, we need to know that Azure networks don't support the use of subnet masks. They only allow you to subnet by using CIDR notation. This isn't a big deal if you don't know what your CIDR equivalent is. Just jump on your favorite search engine and search CIDR reference table. The results will bring you a nice chart which you can use to find what CIDR notation to use. This is more of a continuation from the previous slide. In this slide I thought it would be good to show you how the virtual network creation interface works. This is the first wizard you will come across when you start building your Azure network. This module won't contain a complete guide to building an Azure network, as we'll be doing that in the demo, but this should give you some understanding of what to expect when creating a new Azure network. The virtual network wizard creates the bare bones of a network. From there you will be able to configure it as required. If we just create a virtual network, we will be able to put some servers in it and they'll be able to talk to each other internally. At this point there is no gateway in our virtual network, so we won't be able to establish a VPN to it. We'll be covering this off later. So the images on this slide are screen snippets from the Azure portal which show you the steps which are involved in creating a virtual network. The first step is to name the virtual network and select what location or data center you want your network to reside in. This is the geographic location and you'll want to select the one which is closest to where you live. You may notice that in the screenshot the location I have chosen is Australia East. This is a new data center which opened recently. There is also another data center in Australia's southeast. These two data centers are the closest for people in this part of the world. In the second step, we can create an entry for a DNS server and configure a site-to-site VPN. We are only interested in setting up DNS at this point, as we will configure the VPN manually. DNS is configured by entering the IP address of a DNS server and then giving it a name. In the third step, this is where we can configure our address space. You enter in the start of the network address and then select the size of your network using a CIDR notation. Under CIDR is a list of notations which you will select one of, and it will size your network accordingly. If you look on the far right, Azure tells you the range of addresses which will be used based upon the CIDR notation you have chosen. If you want to, you can also name the subnet to something more useful. Where it says subnet-1, you can type a more meaningful subnet name, such as servers or production. Really, it's up to you. Below there is a button which will allow you to add another subnet into the address space. You can divide your addresses up or just have one large network. This depends on what your requirements are. I will mention this now, that when you create a virtual network, it doesn't provision any space for a gateway subnet. So when it comes time to create a gateway for the VPN to connect to, you will need to make sure you have enough allocated room for a /29 network inside your address space. For example, say we have a /24 address space, which has 254 possible hosts, but only really need a /27, which has 30 hosts. We can size the subnet inside our address space to a /27, which would leave room for a number of other networks. One of these networks will be the /29 for the gateway. If you create an address space with only a /24 and then make your subnet a /24, you will have used all the available space, and now we don't have enough room for a gateway network. The solution could be to increase the size of the address space to a /23 and keep the /24 subnet, or reduce the size of the subnet and keep the /24 address space. Either is an option, but increasing the address space would be the better option, as it allows us to grow the network later on. I know this sounds confusing, but I'll explain during the demo, and you'll be able to see what I mean. Now that we know what our address space is going to look like, we can start to piece together our network diagram. So what will our demo environment look like? I've designed it based on the diagram here. So what's going on in this picture? Well, we have two sites, Wellington and Seattle. At each site we have a firewall. These firewalls don't support dynamic VPN routing, so we also have a Windows 2012 R2 server with routing and remote access services installed on a virtual machine at each site. There is also a site-to-site VPN between the two firewalls in Wellington and Seattle. This allows for connectivity between the two offices. We're not going to be dealing with this particular VPN, as it doesn't play a part in our multi-site VPN configuration. Both sites will have a VPN established from each RAS server to Azure. This is what we will be setting up in the demo. The VPN is established to a single virtual network, so we need to set up a multi-site VPN to make this work. Let's build a list of components we need in order to make this work. Firstly, we're going to need to set up a virtual network, and on this virtual network we're going to create a gateway with dynamic routing, and this will give us our public IP address. This IP address is assigned to us by Azure, so we don't need to go hunting for one. We're also going to need to set up some remote networks in Azure so the VPN knows which networks are on which site. As I mentioned before, we're creating a multi-site VPN, so we're going to have two VPNs connecting to the Azure gateway. These will allow each site to talk to some of the servers which will be hosted in Azure. So this covers off the Azure portion of the VPN. We're going to be looking at what is required for the Wellington and Seattle sites next. Now we're on to planning our on-premises environments. So what do we need to do to our on-premises environments? Firstly, we're going to want to build a Server 2012 R2 machine at each site if our VPN device doesn't support dynamic routing. Since our VPN devices in the demo don't support dynamic routing over VPNs, we're going to go and install Windows 2012 R2 on a virtual machine in the Wellington and Seattle sites. If you want to use physical machines instead of virtual machines, this will work just as well as a virtual machine, the only difference being virtual machines are easier to set up and work with compared to their physical equivalents. We will need to talk with our network teams and get a public IP address for each site and private addresses for each site. Now would also be a good time to get switch ports for the servers configured if they're not already. This includes virtual switches for the virtual machines if you're using virtual machines. In Module 1, we talked about the prerequisites for setting up a multi-site VPN. Now is a good time to remind ourselves of what the requirements are that we need to meet to get RS working with Azure VPNs. The requirements which relate to on-premises are a VPN device which supports dynamic routing over VPN, public IP addresses with no network address translation, Azure PowerShell modules installed on RS servers, and Notepad or your favorite text editor. Our virtual servers we set up will need to have routing and remote access services installed on them, and the servers will need to have 2 network adapters. The first network adapter will connect to a publicly addressed network. This means that the first adapter will need to have a public IP address assigned to it. The other network adapter will be connected to our internal network and will allow us to connect to the servers internally. At this stage, we need to make sure that we're not using NAT on our firewalls for the RS servers, as we need to have network traffic connect directly to the server and not get translated from a public address into a private address. Network address translation means that in your firewall there are 2 entries, a public IP address and a private address. These 2 addresses are tied together so that when traffic enters the firewall from the internet, it arrives destined to the public IP address and then gets translated into a private IP address. This is typical of most home routers where you have a single public IP address and an entire address space of private addresses. This series isn't going to cover NAT, but I thought it would be helpful to some to outline what it is. Our server will need to have a public IP address set in the Windows Network Adapter settings, and this adapter must use the default gateway of the upstream network, so traffic by default will go to and from the server via the public network. We will have another adapter which will have a private address assigned to it, and this will not have a default gateway. At first, we will not be able to access our other servers without setting a persistent route. During the demo, I will explain how to set this route so LAN traffic goes via the private interface and not the public. This brings us to the end of Module 2. I'll see you again in Module 3.